Hello everyone, I am Arıcı. I'm an electrical electronical engineering freshman at Bilkent University, and today I will be conducting an experiment under Physics 101, and the experiment is the conservation of energy with two differing masses. For this experiment, we will obviously need equipment, and the equipment is as follows. An air table with its accessories at the physics laboratory, a scale to measure the weight of the pucks, a ruler, and a spring. So let's continue. Firstly, we start by weighing the single puck. For the sake of our calculations, we will estimate the given value as 423 grams. Secondly, we set our spring in such a position that it is stretched an equal amount of 14 centimeters in both edges, so it follows a diagonal motion. We place our puck of 422 grams to extend the spring a distance of 7.6 centimeters. This value will be important later when calculating various physical quantities. And as you can see, our puck followed a stable diagonal motion just as planned. The air table recorded some dots on our paper so that we can track the motion afterwards and record its displacement related to time. To conduct the second part of our experiment, we will first weigh an individual puck without its top, to then add the two values to get the final mass of our second puck, which is roughly 805 grams. With the same string set up the same way, our second puck also follows a diagonal motion. However, slower than our first puck, as we will observe later. By the tables we have set up, we can see that the conditions we operated in were fairly sufficient, since the minimal changes in the puck's velocity are far from skewing our results. And this second table shows the other physical quantities we have calculated, and relatively low energy loss further supports our previous claim that the conditions were sufficient. The third table represents the second diagonal movement. With the heavier puck, and due to the general equation for kinetic energy, we can see that the puck sacrifices some of its velocity for its gain of mass. The fourth and final table shows us the calculated values for the second puck. However, the energy loss of this puck is lower than the first, so it shows us that a significant amount of the energy lost is not from friction, but another source.